Okay, today we're going to look at repeated percentages, which is often called compound interest. So I've got an example for us today. £100 is placed in a bank account with an annual interest rate of 7%. How much will be in the account after 5 years? And this is a compound interest problem. Simple interest will be just working out 7% and then adding it on 5 times. That's what we call simple interest, but this is compound interest, and that means that each year's amount is built onto the next year. So we have to take it year by year. So in year 1, we start off with £100, and I'm going to use the decimal multiplier method here, even though the first bit I'm sure you could probably do in your head. But we've got £100 and we're going to multiply that by 1.07. That's the 7% increase, and that turns out to be £107. Now the compound interest means for the next year we actually start with £107 and then increase that by 7%. So we keep repeating the calculation. So I'm going to use my calculator here. 107 times 1.07 is £114.49. Keep this on your calculator, and then we use this for our next year. £114.49. Once again, a 7% increase. Multiply that by 1.07. And I get a number on my calculator that's actually got 4 decimal places, but I'm going to round it to 2 because it's pound and pence, but I'm going to keep the full number on my calculator screen so we've got more accuracy. So £122.50, once again multiplied by 1.07, gives me £131.08. Keep that long number on my calculator, and once again multiplied by 1.07, and I end up with £140.26. And that's how much is in the account after 5 years. This is quite a long process. I need to work out what 1 year is before I can go on to the next. However, there is a much quicker way. Because I was keeping the number on your calculator, I'm sure some of you will have realised that what I've actually done is started with my original amount, £100, and then multiplied it by 1.07, and then multiplied that by 1.07, and then multiplied that by 1.07, and then multiplied that by 1.07, and for a 5th time. And using indices, we can rewrite this as 100 multiplied by 1.07 to the power of 5. And what we can do is we can do all the 5 years all in one just by using this calculation. Once again, you need to use your calculator. You need to know how your power key works, but you can simply type in 100 multiplied by 1.07 to the power 5, and you get to the same answer straight away. So this is a much quicker method, and we've got a general rule here. We can do the original amount multiplied by the decimal multiplier raised to the power of n, I'm going to call it here, which is the number of increases. So if we've got a large number of increases, maybe 20 years or maybe in months or days, we can do this very quickly on our calculators. For my second example, this really shows how powerful the method is and how quick using a calculator can be. So this time I've got a car decreases in value by 2% each month. It's originally worth £12,000. How much is it worth after 3 years? So if it's after 3 years and it's decreasing monthly, that's 36 months. So if I was doing the method I used previously, I'd have to do 36 separate calculations. But as it is, I can do it all in one calculation. So I start with the original price, 12,000, and I multiply it by 0.98. Remember from a previous lesson, if I decrease by 2%, that's like having 98% left. So I'm multiplying it by 0.98, that's 98%. And I'm going to do this 36 times. 3 years is 36 months, so I'm actually going to do it to the power of 36. And with a good calculator, I can just type this straight into my calculator. 12,000 multiplied by 0.98 to the power of 36. And the answer comes out at £5,798.56. So that's the figure after 3 years, and I've done it all in one calculation instead of having to do a repeated calculation 36 times.